Welcome to the 22nd module of chapter Light. In this module, we are going to study the ray diagrams of the image formation by convex lens. First of all, we can just understand the image formation by convex lens when the object is kept at infinity. So only the parallel rays comes from the object at infinity to the surface of the lens. After getting refracted, these rays will pass through the focus point, and these two rays are meeting at a point in the F2. So the image is formed at F2, and when we keep a screen here, you can obtain the image here at the point F2. So image is formed at F2, and it is a real image, inverted image, and highly diminished image. Now let us understand the next position of the object. How we can draw the ray diagrams when the object is kept at a position beyond 2F1. So let us consider the object as AB. The straight parallel rays to the principal axis comes and touches the lens, gets refracted and pass through the focus point F2. Now the next ray we are going to consider is the ray which is passing through the optical center. What will happen to the ray which passes through the optical center? It will go without undergoing any refraction. So these two rays are meeting at a point between F2 and 2F2. So the image is formed between F2 and 2F2, and it is a real and inverted image. And we can obtain this image on a screen. So image is formed between F2 and 2F2. Real and inverted image is formed, and it is diminished one because it is smaller in size when comparing the size of the object. Now let us understand what will be the ray diagram when the object is kept at the position 2F1. Here also we can consider the parallel ray of light to the principal axis. After touching the lens, undergoes refraction and pass through F2, focus F2. Consider the next ray of light coming from the object AB, that is passing through the optical center. What will happen here when a ray of light passes through the optical center? It will go undeviated. So these two are joining at a point and forming an image exactly at the point 2F2. And when you just observe here, the height of the image is equal to height of the object. So here we are getting an image at the position 2F2 when we keep the object at 2F1, and it is a real and inverted image, and the size of the object and the image is the same. We will be obtaining a same sized image. Now we can consider the next position of the object, that is between 2F1 and F1. Here also we will be having the straight parallel rays to the principal axis. After touching the surface of the lens, will undergo refraction and passes through F2. Consider the next ray of light which is passing through the optical center. What will happen to the ray of light that passes through the optical center? It will go undeviated. So these two rays are meeting at a point beyond 2F2. And when you observe here, we can get the size of the images greater than the size of the object. That is, we are obtaining an enlarged image here, and it is a real and inverted image, and the position is beyond 2F2. Beyond 2F2, a real and inverted image which is larger in size is obtained. Now let us see the next position of the object, that is when the object is kept at focus point 1F1. Here the parallel ray to the principal axis after refraction pass through the focus point F2. Next we can consider the ray of light which is passing through the optical center goes undeviated without undergoing any refraction. So here these two rays are not joining. So we can consider that they might be meeting at infinity. So we can take image is formed at infinity, and it will be a highly magnified image if it is being joining somewhere at infinity. And it is a real and inverted image too. Now we shall see the last position of the object, that is between F1 and optical center, that is very close to the lens. Here also we can consider the parallel ray of light after refraction pass through the focus point 2. Next we are going to consider the ray of light coming from the object passing through the optical center, goes straight without undergoing any refraction. So here the two rays are not joining anywhere, but when you just extend these lines backwards, it is about to be coming from a point. And that point is where? On the same side of the lens as the object, and it will be beyond 2f1, and it will be an enlarged image. But here there is one difference in the image form, that is virtual and erect image we are getting, and it will be a magnified image. We can obtain the image only inside the lens, not on a screen. Here is the nature of the image formation. Thank you.